All right, guys, welcome to Module 10, Joint Fit Up and Alignment. Upon completion of this module, you'll be able to identify and explain job code specifications, use fit-up gauges and measuring devices to check joint fit-up, identify and explain distortion and how it is controlled, fit up joints using plate and pipe fitting tools, check for joint misalignment, and pour fit-up before and after welding. Performance tasks, fit up joint using plate and pipe fit up tools. Check the joint for proper fit up and alignment using gauges and measuring devices. Okay, here's an example of some different codes that are out there. The one on the left is the ASME Section 9, which is the boiler and pressure vessel code. And then the ASME B31.1 is power piping. And then the one on the right is AWS D1.1. Okay, code changes. The AWS code indicates additions to the code with a double vertical line in the margin alongside the changed area. Editorial changes to the AWS code are indicated by a single vertical line. The SME updates the entire code every 3 years. An addendum is issued yearly. The yearly addendum is identified by placing the letter A in front of the year on the cover of the code. Okay, here's an example of a WPS. Basically what a WPS is it's kind of your roadmap for what you're going to do as far as creating a weld. So it kind of gives you all the parameters, what the joint should look like, the type of base metal, type of filler metal, amperages allowed, positions. It just kind of tells you everything you need to know to perform the weld. A weld procedure specifications is a written set of instructions for producing sound welds. The requirement for the use of a WPS is often listed on job blueprints as a note or in the tail of the weld symbol. The results of a testing record are required on a procedure qualification record. The only place that this may not be required is if you're using a pre-qualified design as laid out by AWS D1.1, which the qualifications that you guys will test for in this class are all done based on pre-qualified joint designs. Okay, the centering head is used to measure round stock and locate the center of shafts and other objects. So that's on the combination square shown on the bottom right. They do come as combo sets like that. So you have the combination, the protractor, and the centering head all as one unit. I do have one of these in class that I can show you guys and demonstrate how it's used to find the center of round objects. All right, levels use a bubble in a glass vial to check level and plumb. Okay, for those of you who don't know, plumb is just another, is just a industry-specific word or in the construction trades that's used to indicate that something that is placed vertically is truly vertical. So like if you're setting posts for a fence, or if you're in the oil field setting posts for supports, you would check them with a level to make sure they're plumb, to make sure they're true vertical. And placed correctly. Also, when working on larger items, instead of using squares, framing squares, or combination squares, a level can be used in place of a square. If you have a horizontal beam that is level, and then you have to put a vertical, you have a vertical beam coming up off of that one. If it's plumb, then those pieces would be square also. Okay, checking for internal misalignment. These gauges here, I actually have the two different styles. I have this style and then the style that'll be shown on the next slide. These are to check alignments, misalignments in pipe. What we have to remember when we weld pipe is the pipe is man-made and not perfectly round. And so at times you will have some misalignment between the pipe. You have to try and minimize that though, for the better, to try and get the best fit up. One, so that your weld is better, but then also so that it's in alignment with the code. Okay, here's the other style of high-low gauge that can be used for alignment as well. Here they're just measuring plate material thickness. Like I said, I have both styles. Okay, here's a little more, here's some detail on the alignment gauge. Internal misalignment checks. To check for internal misalignment, high-low gauges have two prongs or alignment stops that are pulled together or pulled tightly against the inside diameter of the joint, so that one stop is flush on each side of the joint. Okay, measuring weld reinforcement. So here this is on a piece of pipe, and when we look at weld reinforcement, that's how much weld is actually above the top of the plate, or the outside of the pipe, top of the plate, and this is specified in code how much is allowed. Okay. Okay, this is for layout. If you're putting a socket fitting onto pipe, sometimes there's a gap distance that's required so that as you weld and the pipe expands, it doesn't actually pull away and crack the weld. Okay. This is just using a hydraulic jack for fit up. Hydraulic jacks are quite handy because they are very portable and they're quite powerful, and can be used to align parts or even push parts into place that have started to distort. Okay, chain hoist. Secure the chain hoist over the weldment with an appropriate sling wrapped around a structural member. Okay, so as we see in the illustration, they're using a wire rope sling to support the hoist, and then looks like a nylon or a sling that's being used to lift the weldment to align it to get the weld joint into place. All right, here's just a couple different styles. We have a come along and a chain fall, which I have both of those in the shop we can look at. Okay, strong backs. Strong backs are sometimes used when aligning a joint to keep distortion from pulling the joint closer together. As you guys have seen doing your bead pads, the heat that's input will start to actually warp the plate. And when you do qualification plates, it can also cause quite a bit of distortion at times. Okay, this is just an alignment tool, yokes and wedges. So you can see that yoke is attached to a plate that the two beveled plates are set on top of, and then the wedge is used to push them down firmly so that they can be aligned and tacked in place. Okay, joint alignment with a strong back. So again, we're using yokes and wedges over the top of a strong back to pull plates into place and align them. Okay, here's a plate alignment tool. And this, goes through the joint opening. Then the root bar is put in. And then you can tighten down the adjusting rod and pull the two plates into alignment. Okay, lots of illustrations in this one. This is a pipe alignment tool so that you can align large 90-degree fittings onto pipe. Here's some clamps and wedges. These again are used to align pipe into place. It's very important. These alignment tools, there's so many different tools for different applications. A lot of the work that you'll do actually welding, you'll spend a lot of time prepping so that you get things aligned and fit up properly, just to make it easier to weld. It's quite hard to overcome poor fit up while welding. There's a rim clamp. As you can see, there's a lot of adjustment on this clamp to bring things into proper alignment. Here's some other styles of pipe clamps. I have a few different styles out in the shop we can look at, and these are all used just to align, pipe fittings and just pipe to pipe. This is actually a puller tool, and what can be done here is you get the two pipes clamped, and then there's pull bars so that you can pull the pipes together to get them into alignment. Here's a flange alignment tool, which clamps onto the pipe and then onto the flange to help line it up. Okay, controlling distortion. So as you weld, as I talked about your bead pad, what is happening when you weld across there and it's heating and cooling is you start to distort the plate, and it starts to pull and bend. So when we heat things and when we weld things, we need to be mindful of this. And as we weld, we need to be welding in a fashion that we have welds heating and cooling kind of against each other, equal forces. So like on a square frame, you would weld opposite corners. You wouldn't start in one corner and just go around like clockwise to every corner. You would bounce around. The other thing is, as you heat steel, as we look at in the figure here, if you heat a block of steel within, in between something where it can't expand, what'll happen is it'll actually expand, and it'll expand in the two directions where it's not limited. But then as it cools, it'll actually change the shape of the steel. And so it would then fall out of there if you had it like in between two jaws in a vise, and it would expand. And then as it cooled, it would actually shrink and fall out. Okay, thermal expansion and specific heat per unit volume for common metals. This is just when the metal's heated, how much it will actually increase in size, how much expansion. Okay, stress and distortion of welds. The degree of distortion is directly related to the stress generated during welding. Okay, so we have a few different illustrations here of how distortion can be created when welding. And we've seen a few of these in the class already. Okay, weld reinforcement. Weld reinforcement has to do with the amount of metal, the amount of weld metal that is reinforced in excess of the surface of the plate. So you look at maximum reinforcement there in the top illustration. When we're doing plates for welder qualification, that 1/8 inch is the max reinforcement. And if you're in excess of that, the weld is out of spec and thus is a fail. When you look down at fillet welds, like on the bottom there, if you end up with excessive reinforcement, like on a convex fillet weld, that's when you start to get cold laps and slag traps, and it can actually, it affects the visual appearance of the weld, but it can also affect the strength of the weld considerably. Okay, open V-groove preparation. This is, we will practice these plates mainly in preparation to weld pipe, because the way that the joint setup is done is identical to pipe. Here's some other groove designs. We did go over this in a prior chapter. You guys should understand these. All right, so if we look at the backing strip weld there in the middle, that's going to be the weld you guys start with initially for qualification. All right, gas backing. This is a system that's done when they weld mainly stainless steel, like food grade stainless in food processing plants. So the gas shielding is inside the pipe. You purged all the oxygen out. You're welding from the outside, and that shielding on the inside allows you to have a nearly flawless weld on the inside of the pipe, as long as it's welded correctly. Okay, these are backing rings, which could be consumable rings that are put inside pipe. So then as they're welded, they're either become part of the weld metal or are consumed by the heat of the weld. Okay, here's some illustrations of backing rings in place. Some different consumable insert shapes. Some illustrations of those in place. We won't actually use any of these in class, but be aware that they are out there and are used. Okay, here we look at the gap or a ring gap. like I said, what these are done for is as you weld around there, that pipe has to expand, and it will expand into the fitting. If the gap is not there as it expands into the fitting, it will actually cause the weld to fail. All right, backstep welding. This is done to help minimize distortion. So you're taking the weld in small chunks and welding back towards the welded area to help minimize distortion and pull. Okay, intermittent weld sequences. Intermittent weld sequences are to also help mitigate distortion. So as you can see in the groove weld, we're welding, you know, the welds in the root first, and then the cover passes last. And then in the fillet welds, we're alternating sides as we go through there. We're not just solid welding both sides. Okay, and here's just some an illustration showing some different different terms and how they relate to edge preparation and plate. All right, guys, that concludes the Chapter 10 PowerPoint. Be sure to complete the quiz and discussion post prior to the test. Have a good day. Thanks.